Welcome, dear learners. This is Aishwarya, Assistant Professor, Department of Chemistry, St. Joseph College of Arts and Science for Women, Hosur. We are going to see about the hard acid and hard base. Before that, we have to conclude the Arrhenius acid, Arrhenius Bronsted, and Lewis acid base concepted. So, Arrhenius acid, any substance when dissolved in water, increase the concentration of the hydrogen ions. Bronsted Lowry acid is a proton donor, base is the proton acceptor. In Lewis acid and base, acid is electron acceptor, and Lewis base is the electron donor. In Arrhenius bases, a substance when dissolved in water increases the concentration of the hydroxyl ions. So hard and soft acid and bases. Characterization of hard acids. Hard acids are cations with small size. In different oxidation state, the hard acids are cations of higher oxidation states. Hard acid does not possess large number of valence electrons. In soft acids have cation in large size. So cation have usually zero or low oxidation state. Soft acid with large number of valence electrons. So hard acids are low polarizability, high positive charge, small size, not easily oxidized. In hard bases, low polarizability, spread donor orbital, high electronegativity, not easily oxidized. In soft acid, uh, both are high polarizability. Then it is a low positive charge and large size, easily oxidized. In soft bases, diffuse donor orbital, low electronegativity and easily oxidized. So Pearson hard soft acid base classification of acid and bases. So acid and bases of hard acid and soft bases. So Pearson in 1963 introduced the terms of hard and soft to describe the member of the class 1, class 2 respectively. So class 1 types metal ions is hard acids, class 2 metal ions soft acids. Class 1 is the type of ligands are hard bases, class 2 types of ligands of soft bases. So hard acid prefers to bond with the hard base, soft acid prefer to bond with soft bases. Classification of acid and bases. Then the applications of hard and soft acid base principle. First one is the stability of the complexes. Stability of the complexes. A complex would be the most stable if the metal ligand both are hard or soft. Examples. The AgI2 is stable but AgF2 is not. Then the prediction of coordination in complex of ambidentate ligands. So HSAB principle can also predict the formation of various metal ion complexes with ambidentate ligand. So ambidentate ligand is a monodentate ligand which can coordinate the metal ion through more than one coordinated atom. So SCN is ambidentate ligands. It can coordinate it through N or S. So thiocyanate is a particularly interesting ligand. It is an ambidentate ligand. It can be bind to metal ion either through S or the N. It prefers to bind to soft metal ion through the S and to the hard metal ion through the N. This can be in the structure of N bonded thiocyanate and S bonded thiocyanate. Classification of acid and bases. The acid and bases can be classified as the hard and soft depending upon their preference for the hard and soft reactants. For example, a given base B may be classified as the hard or soft base on the equilibrium. There is a computation here between acid H plus and CH3 Hg plus. So if B is soft, then it goes to the right. If B is hard, then to the left. So next one is the occurrence of ores and minerals. Certain metals can be explained on the basis of Pearson HSAB principle. Hard acid metal ions such as magnesium, calcium occurs mostly as their oxides, carbonate, halides. The next one is the poisoning the metal catalyzed. Poisoning the metal catalyst. Some metals nickel, platinum, palladium, chromium, molybdenum act as a catalyst. These metal catalysts easily poisoned by the substance like the carbonyl, unsaturated carbon, hydrocarbon, phosphorus, arsenic containing ligands. The soft acid catalysts are not affected by the hard base or ligands containing nitrogen, oxygen, and fluorine. So poisoning attributed to the soft acid soft base interaction between the soft metal ion and the ligands. The ligands are strongly absorbed on the surface of the metal and block the active sites. So theoretical basis of this hardness and softness. Several theories have been explained the stability of the complexes by the hard and soft of interaction. Some of the theories are: first one is the bibonding theory. In this theory given by the Mulliken in 1955 and Chad in 1956 to explain the soft interaction on the basis of bibonding theory. The acids have low oxidation state and large number of d electrons. They have a strong tendency to form the bibonds with soft base, which are also bibonding ligands. The polarization of soft acid and soft base also favor the bibonding. So next one is the electrostatic interaction. This theory, ionic bond is formed by the interaction of hard acid and hard bases. So hard and hard interactions are purely ionic and electrostatic. The electrostatic attraction between two ions will be greater. The resulting compound formed by hard bases will be highly stable. Then the polarizing power and polarizability. Then the electronegativity of hardness and softness. So high electronegative species are hard, low electronegatives are soft. The covalent bonds is formed by between the interaction of soft acid and soft base. It has a large size of the effects are explain the interaction. The transmetal ion having the 6 or d electron. The d subshells are easily polarized. Therefore, the soft acid and bases have covalent bondings stable. Though he acid base strength and hardness and softness. Limitations of the Pearson hard soft acid base principle. So it's usual concept, but no doubt, but it's some tricky limitation. The prime limitation is general and has no any direct quantitative scale of acid base strength. The inherent the acid base strength are not accounted for. Example, hydroxide, fluorine ions. Both are bases where OH minus nearly 10 to the power of 13 times. Sometimes the hard soft principle fails to keep the party with the inherent the acid base strength. The reaction must be favored in the use of soft combination between methyl and hydrogen ions.